In today's lesson, we're looking at compound interest. Under a system called compound interest, the interest is added to the principal at the end of each year. So in other words, it's compounded annually. And we're going to have a look at the actual compound interest formula a little bit later on, which is this one. A equals P bracket 1 plus R to the power of N. So probably the easiest way we can think about compound interest is to have a look at this table here. So what we can do is we've got $1,000 investment, which we call the principal. And we receive 10% compound interest on that. So we receive 10% of the $1,000. So that's 100. And we add that to get a total figure at the end of the year of $1,100. Now, normal interest would just continue to pay out the $100 year on year out. But with compound interest, we actually take this $1,100 and that becomes the principal for the second year. So we therefore pay the 10% interest on $1,100 rather than on the 1,000 that we started with. So that means the interest in the second year is $110. So we can see that there's a $10 difference between those two values to make our total interest at the end of the second year $1,210. So again, that $1,210 then becomes the principal in the third year, and we can start to see that the value of our interest continues to climb. So in the long term, there can be significant increases or differences between compound and simple interest. So it's not going to be practical for us all the time to be able to draw up a table like this one in order to be able to calculate our compound interest values. So that's why we use our formula. Now, going through our formula, we have A is the final value of the investment. So in our example above here, it would be this 1331 would be A. P is the principal, so that's the initial starting amount. So that's the $1,000. We have the interest rate. We're not told the interest rate here, but we know that this is 10%, so the interest rate is 10%. And then we have the number of investment periods. So in this example here, we've got 3 years, so it's 3 investment periods. Now, for the most, it doesn't have to be annually, so it doesn't have to be paid per year, but that's what we'll see probably in most of our examples, is that the interest is paid annually. So in our first example that we're going to work through here, we're asked to find the value of a $40,000 investment paid at 7.5% PA, so that's per annum, and compounded annually for 8 years. So what we're going to do is plug the values we know into our formula. So first thing we do, we write our compound interest formula. We don't know what A is, so we don't know what A is equal to, but the principal is equal to $40,000. The interest rate is 7.5%, and the number of investment periods, N, is 8. So we've got all the information we need to be able to plug into the formula. The only thing we do need to be aware of, however, is that the rate actually isn't written as a percent, it's written as a decimal. So what that means is we need to turn the 7.5% into a decimal, and that's 0.075. Okay, so now we've got the values, we can plug that into our formula. We've got A equals the principal, which is 40,000, 1 plus R, so R, this point is 0.075 to the power of 8. And we can just simply plug that into our calculator. So we've got 40,000 times by bracket 1 plus 0.075 close bracket to the power of 8 equals $71,339.11. So our total return, our total amount for investing $40,000 at 7.5% over 8 years is $71,000. Now the second part of the question asks us how much interest is earned on the investment. So what we need to do is take our initial principal amount, which was $40,000, and minus that from our $71,000. And we're paid $31,339.11.